back to the good old days again. Monday, everybody, and welcome to another week of e-learning. And so we're kind of to the midway point in this last week of April, and so we have a lot of things to get through today. Mondays in class, remember, used to be very busy. We had a lot of papers to pass back. Well, we're not passing papers back, but we are going to have regular old logic problems this week that I'm going to give you hints to, and we have a couple opportunities for competitions. One is we are in the final four, and we'll get you a finalized date on that. But if you look, we made it to the final bracket, and we made it through round one, round two, round three, round four, and then there were four. And you notice that one of the teams left in the four. I don't know if they entered twice and split their team in half, but there's two of them, and so I don't quite know how that works. Hopefully it's all above board, but we'll see. And so make sure that we're ready for that. And so it might be this Friday. We'll let you know. And then also we have, if you look, there's going to be an academic Super Bowl competition that's going to be individual. And so if you would like to take that, if you click on the link, it will lead you to the syllabus of everything we were supposed to cover. Now, we've covered a lot of these things. Probability was 50%. But then exponential functions, we never got a chance to practice those and to review those. And so if you want to, you can go on Khan Academy, and you'd have to look under Algebra 2 and go to exponential models. And also there's one called, now I lost it, but exponential models, and then figuring out what this constant E is. And exponential models here, and then more exponential models here on how to construct exponential functions. And so rational exponents and exponential functions. And so just look at the syllabus here, and then I will give you more information on Wednesday. I think we can start taking it individually. It'll be a Google form. I think it'll be 30 questions. I think you'll have around 40 minutes. You can use a calculator. And then the last thing is on the academic Super Bowl competition is functions. Identifying if it is a function, if it passes the vertical line test. One-to-one functions we don't talk about too much in Algebra 1, but those are the functions that are a function and the inverse is a function. So not only does it have to pass the vertical line test, it has to pass the horizontal line test. And so knowing what the domain and range is, parallel and perpendicular lines, slopes, y-intercepts from data, and function notation. And so we should feel good about this stuff. Even pre-algebra, we're starting to cover this. And then the probability things, the only one we would be, oh, there's Kaya. Hello, how are you? And so the only one we'd be a little shaky on is the exponential function. So if you're serious about taking this, you might want to brush up on that, and I'll get you more information and get you the link. And so I did know, I got an email that when we do compete, you want to pick Northridge Middle School of Middlebury, Indiana, because there is another Northridge Middle School maybe in Crawfordsville. And so you might have to ask Lincoln and Kirsten about that, Crawford. But otherwise, we'll pick Northridge Middle School of Middlebury, and we should be good. So that's coming up this week. And we have a good chance of doing really well because I see Discovery didn't sign up. So we can get this. And so make sure we'll participate. And so let me know about that. And so we have that. We have the two competitions. Make sure you take attendance. Most of you are. You need to get into a routine. And so I get up, I do certain things in order. I see some of your routines like 10 o'clock at night or sending me homework at 12:02 a.m. And so not a good routine. Good routine. Get up, get these things done, get dressed up, and I'm ready to go. And so get into a routine. We have several more weeks of this. 5 more weeks. 5 more weeks at 12 a.m. is not good. And so we need to make sure we have that. Email me. Let me know. I'm going to get grades in the Power School. And so we want to get all that done. And so make sure you let me know if you need anything. So you will notice this week whether geometry, algebra, pre-algebra, we got logic problems number 31, and we want to give you some hints on these. And so just like good old days, and where I used to stand and teach, much better than the sitting and teaching, too much sitting around. And so on the logic problems this week, the first ones, you're only allowed to use these numbers, a 50, a 20, a 10, a 5, a 2, and a 1, all of which used to be denominations of coins. For all of you numismatists out there, there was a 2-cent piece and a 20-cent piece. In fact, the 2-cent piece was the very first coin to ever say "In God We Trust" on it during the American Civil War. I think it was 1864. And so, but you can only use these 6 numbers, and you can use them as many times as you want. And you got to get the rows and columns to add up to the numbers I gave you. So if I say this row adds up to 110, you can only use 50s, 20s, 10s, 5s, 2s, and 1s. If this column adds up to 111, this column adds up to 13. And then we need to know where we're going to place these. Well, first of all, if you're going to use all 20s, 20, 40, 60, 80, you wouldn't get to 110. So you need a 50. And if I put a 50 here, you know the 50 can't go in the 13 column or the 11 column. It could go in the 82 column. But look, if I did 50, this would be 20, 40, 60, and that'd be 110. But you can't even use 20s in these columns. So that means I'm going to need another 50 right here. And I know those are both 50s. Well, if that's a 50 and the other one's a 50, I need to get to 10. Well, the one way to get to 10 is 5 and 5. Can't do 10 and 1, can't do 2 and 2, so pretty much this is going to be 5 and 5. And I know this right away. Then, if I go 13 here or 11 here, that means these 3 have to add up to 6. And that means the other ones have to add up to 8. Those are adding up to 6. These are adding up to 8. And so, but I'm going this way, and I'm adding up to 6. Well, I know in this column right here, to get to 6, you can't do 5 and 1 because you can't use zeros. And so the only way to get to 6 would be 2, 4, 5, 6. 2, 2, 1, 1. Of course, I don't know the order of this. Now, to get to 77, 20, 40, 60, see, I need a 50 in this. And the only column that could have a 50 is this one right here. Would have to have a 50. And then the rest of this would add up to 27. Well, to get to 27, it'd be a 20, a 5, and a 2. We can't have a 20 in this column, and you can't have a 20 in this column, so the 20 is going to have to go here. And then this is either going to be 5, 2, or 2, 5. Well, it can't be a 5 here because you'd have to have more than 1, so this would be a 2, and this would be a 5. And then here I need a 12, because I already got 70, and I need a 12. Well, I can't put a 10 here, so the 10 would have to go here. And then this would be a 2. Well, then, if I got a 10 here, then this is a 14. Well, how in the world are you going to get a 14? Well, that'd be a 10, 2, and 2. Well, you can't put the 10s in these columns because this would add up to too much. So this would be a 10. And then this is 50, 100, 110. There's my 1. 10, 12, 13, 5, 7, 9, 11, and I'm done. And I just did one for you. You write it down. You send it in. I even said due Saturday. Some of you are like, when exactly are the logic problems due? They're due at the end of the week. If you send them too late in the weekend, I won't get them in the Power School maybe for another whole week because we'll get the grades in. I have a bunch of grades I've graded, but I need to put them in Power School, which is going to happen after all these videos are made and answering your emails. And so if you don't get them in soon or right away, it might not make the first cut. And then it sits in the pile till it gets into the second cut. And so the best thing to do is get stuff in as soon as you can. Okay, so you have 3 more of those. And then down here, I have 2 more questions for you. One is you're using the numbers 1 to 20, each of them once. Most of these squares are going to be empty. On this one, you're only filling 2 squares in each row and column. And so these things are going to be mainly empty. There'll be 2 in every column, and there'll be 2 in every row. Now, how do I know which ones? We are going to write the numbers 1 to 20. I should have typed them out, and then you could cross them off as you use them. But you could do that. You could just write 1, 2, 3, 4, 5, all the way to 20. And you want to cross them off as you use them. And so this is called product pairs. Give me a pair of numbers, and I'm going to get each of these. Well, some of them have more than once, like 48 could be 6 and 8. It could be 12 and 4. It could be 16 and 3. All those are under 20. So you don't start there. You pick a number like 15. Well, that'd be 1 and 15 or 3 and 5. Still too many possibilities. But then here, this is 11 times 12. And that's the only possibility. 170 is 17 times 10. That is the only possibility. Ooh, 17. You know, a lot of numbers 17 doesn't go into. And so when I look down here, wait, this 34 is 17 times 2. So then I know the 17 goes right here, because it goes into 170 and it goes into 34. When I look down here, let's look for 11. Does 11 go into 48? No, 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 yes. So 11 goes right here for the 209. Well, 11 goes into this how many times? It goes in 19 times. Well, which one of these numbers does 19 go into? 48? No. So then I know there's no number here. Does a 19 go into 28? No. Does 19 go into 52? No. Does 19 go into 133? 19 times 7. I think. Yeah, and so that'd be a 19. And then you know the rest of this column is empty, because you have your 19, your 11. And you could circle the 19 and the 11. And then you figure out where the 7 goes. 7 go into 34? No. 48? No. 60? No. 105? Yes. 7 times 15. 7 go into 90? No. 7 go into this? Yes. 7 goes into this 4 times. But can we use a 24? No. And does 7 go into... No, so you know the 7's right here. 7 times 19. And I better stop before I make a mistake and somebody email. You gave the wrong hint on the logic problems. And then you'd cross off this whole column. Okay? Then, for the very last one, we'll move myself to the other corner. Whoa. Maybe we'll move up here. And it says, outline the greatest number of squares of any size such that the edges do not touch. And there's lots of squares here. And then you got to count them. And I got to be able to see it when you scan it. So, for example, you can't outline this square and then outline this one, because those touch. And so if you're going to outline this one, you can outline this one because those don't touch. But then this one touches this one, so then you wouldn't be able to use that one. But if you don't use that one, you could use this one. But it says the squares cannot even touch at a single point. What is the maximum number of squares that you can get? Because sometimes picking a square outlines. Now this square is fine, and then picking this one. Because even though it's inside, they don't touch. The edges do not touch, not even at a single point. So you need to find the maximum number of squares. Show them and write it right here to get all the points. Okay? So we got logic problems this week. We got those competitions coming up. And so make sure you print these off. You can send them to me at the end of the week. And so just trying to get back to the regular old logic problems. And so we're going to get to that. And then time to start the notes. Okay? Just like back in class, we got lots to do. And the sun's coming up and we got lots. Okay? So let's go back to our agenda for today. Okay? And see what we have in store. And so the homework looks really complicated. Page 6, 12, 1, 2, 5 to 7, 12 to 17, 21, 23, 28, 29. But if you click on the notes, there's a handout to do all of those problems. And when you click on it, I have it all broken down. You just fill in the blanks, and it'll be pretty easy. And so it'll keep track of everything, and so you don't have to worry too much about that. But we're going to talk about symmetries today. And so this is notes number 119. And so what it means, most of us are familiar a lot with symmetry, but we're mainly familiar with line symmetry. And so we want to talk about a couple more types of symmetry. A figure in the plane has symmetry if there is an isometry. That means it's going to be the same size. Dilations on your warm-ups this week. When it says, will the sides be the same length? If there's a dilation, unless it's dilated by 1, isometry, it's not going to be. The only thing that stays the same in a dilation is the angles. And so, but symmetry would be same size. There's an isometry other than the identity that maps a figure onto itself. And so there are 3 types of symmetries we're going to talk about. Of course, there is line symmetry, and that's what we're most familiar with. Draw a line down the middle. I'm the same on both sides. And so I have vertical symmetry. That is a line symmetry. And so we think of that, that's a reflection. And so if you put the mirror, we're the same on both sides. Maybe not the little dimple or a mole on your face, but everything else, symmetrical. Line of symmetry, there's a line of reflection. But then there's what we call rotational symmetry. And instead of flipping it to get the same thing on both sides, we turn it. And when we turn it, we end up at the same place. And so this would be a turn. Well, there also is a special type of turn, and that is called point symmetry. And point symmetry, P-O-I-N-T, if I can write. That's pretty bad. Point symmetry means you have a 180-degree rotation. And what do we call, Isaiah, 180-degree rotation? We call it a what? Yes, we call it a half turn. And so point symmetry is if you have a half turn. And so you can have, a diagram can have multiple symmetries, and you're going to have to identify which ones it has. And we'll talk about all that. And so that's what we're going to discuss. Point symmetry, rotational symmetry, which is the new stuff, and line symmetry, which is the old stuff. Okay? And so if we look at these figures right here and talk about, well, what type of symmetries do they have? Do they have line symmetries? Where would be the lines of symmetry? Do they have point symmetry? Do they have rotational symmetry? Avery, give me one type of symmetry that they have. What? Still way in the back. Can't hear you. Oh, yes, line symmetry. So this has line symmetry. And then how many lines of symmetry does it have? Avery, just one? There'd be one right there. But turn your head. Yes, there'd be one this way. And if we turn our head, there would be one this way. So there would actually be 3 lines of symmetry. But then notice we said turn our head. And see, if you turn it, that means there's rotational symmetry. Now, when we talk about rotational symmetry, we talk about the degrees of rotation in it. How many degrees do I have to turn it to get it to where it would be? And so let's take a look at this. Here, if I erase this, nah, that's not the eraser. That's another line. And so if I take this picture right here, boom, boom, boom. How are we doing, Mingo? You like the sunshine, don't you? And so we take this and we click on it. And then the thing is, if I turn it, how many degrees would I have to turn it till it ends up back to where I started from, where bowers of flowers bloom in the sun? And so, how many degrees is that? Well, what you do is you have a circle here. And how many sections do I have? A 1, a 2, a 3. And so if I have 360 degrees in a circle, and there's 3 sections, Jerry, what's 360 divided by 3? 120. And so this has 120 degree rotational symmetry. Now it also has negative 120, so there's 120. Here is 240. Also has 240 degrees rotational symmetry. And if we just do multiples of 120, we would get 360, which is right back where I started from, because that will always work. We have 360 degree rotational symmetry. Yeah, just spin around and sit right back down. But it doesn't have half turn, because the half turn symmetry would put this one up here, and it would be upside down. And these would be down here. And that does not land on the same picture. So that does not have point symmetry. The next problem. What type of symmetries does this one have? Tim, do we have any line symmetries? Yes. How many? Got your head above water out of the swimming pool long enough to answer? Yes. There's one right there. And there would be one right there. So there are 2 of them. Dos. What other type of symmetries do we have? Yes, Raquel? Yeah, we would have point symmetry. That's very good. Because you would have a half turn. If you took this shape, if I can draw it quick, woohoo, and I clicked on it, well, let's get the arrow. Come on. If I spun this 180 degrees, we'd end up where I was. So this does have point symmetry. And so see how we did that? 180 degree rotation. 360 obviously gets you back to where you were. But it has point symmetry. And then, does it have any other rotational symmetries? No, only the point symmetry. Remember, point is a type of rotational symmetry. It's a 180 degree rotation. Okay, so that's the only type has there. What about this one? The star. Does it have line symmetry? Charlie. Yes. Charlie, how many line symmetries? 1 for each corner? Well, how many pointed star is this? It's a 5-pointed star. So that means there would be 5 line symmetries. Now what about the rotational symmetry? If one of the rotations ends up being 180, then it has point symmetry. So we have rotational symmetry. And how many degrees? Well, how many points does the star have? 5. So this is 360 going, or turn around the world in 360 degrees. And so if we got 5 of these, we just take 360 divided by 5. And the easiest way to divide by 5, Carson? Yes, Mr. Nyson? It is to divide by 10 and double it. So 360 divided by 5 is, Carson? 72. And so we have 72 degree rotation, and we have all the multiples of 72 up to 360. So to have rotational symmetry, your rotation has to be a factor of 360. And so all the multiples of 72, you got 72 plus 72 gives you 144, 144 plus 72 give you 216, 216 plus 72 would give you 288, 288 plus 72 would get you back right where I started from. California, here I come on the bright sunshine day. And so you got to identify some of those. Now, then some of your homework's just going to be complete the figure. Well, if it says complete the figure so that has symmetry in line K, that'd be like putting your mirror here, right there, except your mirror was red, so I grabbed the wrong color. And then you would flip it, and so this would go here, and that little circle would go there. On this one, if you're going to put the mirror right here, and we want to draw in the reflection, just turn your head sideways. That would go out 1, this would go out 2, that would go like that. If this is 2 on our square root 2 square root 2, these are all 1. And then this would be there. That would come down to here, go up, and then over. And you could shade them if you wanted. Kind of looks like a little Batman there. But you have that. And then if we're reflecting in line K here, we will flip this way, down, over to here. Remember, the point in the line of reflection never moves. It's fixed. And then this one goes over to here, down, and then over. And so that flipped to that side, and that flipped to that side, and so there's your image. And that would be the line of symmetry for that. Okay? So we're going to have a couple more. Are you ready? And so let's finish up these last 4. It says symmetry in point O. Well, if it's point symmetry, kind of look where the bigger circle is, and that's where you're rotating 180 degrees. So if you had a nifty little button like I do, you could just click on this and see how it would spin. But notice when you do that, you got to put the point on top of where the point was supposed to spin. And so that would be your answer for that one. If I can click off of it. Think I can? Otherwise, I have to redraw it. Now this one, if we were going to spin this in point O, I could trace the whole thing, and I could actually turn it around point 0. And so let's see what happens here when I grab this thing. Woohoo! Point symmetry would be right like that, but then you'd put it right there on that point. And so it would look something like that. It would be point symmetry. Notice it's not a line of reflection. It doesn't flip. It's turning 180 degrees. Now, remember that the rotations, 90-degree rotation, is counterclockwise, which is counterintuitive, but we've been trying to go through that and get that in your head, get the sound off my face. So a 90-degree rotation is we're going this way. And so if I go straight 90 from there, the circle would be on this side. Then if I go 90 from there, the circle, this is pretty bad. You know, on your homework, just try to do the best you can. It would be right there. And see, that is a half turn. And then the 270 rotation would be moving this up here, would keep the circle on this side. So is a 270-degree rotation the same as a negative 90-degree rotation? Yes, yes, yes. And we talked about all that stuff last week. Okay? But then, for a 60, 120, 180, the 180 is right here. The half turn would look like this. So a 60 and a 120, you're dividing this side up into thirds. So 60, nah, it doesn't look very good. 60-degree rotation, it's like cutting a piece of pie. They never let me do it because I never get it right. 60, 120, those look like, you can't trisect an angle with a compass, so you're sunk on that one. And so this would be 60, 120, 180. They should all be 60-degree increments. And so here's my 60. Here's my 120. And there's my 180. And it didn't say to keep going, so I don't have to. And if you accidentally do, it's fine. But it would be 60. That would be that rotation, 120, 180. And so just rotate at that. And so it has rotational symmetry. But would this, you would have to add in, for the end, it wouldn't be symmetrical unless you added the rest, because if I move this 60, that this whole shape would be symmetrical. This just half a shape wouldn't be, and so you would need the whole shape. Okay? So then for your homework tonight, as we look at this, you go to the homework page, what's 1 and 2, and then 5 and 6. Well, if we look at these, it says for problem 1 and 2, consider how many lines of symmetry does it have. Now, this is a starfish. It doesn't have to be perfect. Don't be hypercritical. There's 5 lines of symmetry because there's 5 points on the star. Does it have point symmetry? No, because that tip of the starfish would have to be down here. And list the rotational symmetries. Well, just do 360 divided by 5, and then list all those multiples up to 360. Now this one, this little shape here, whatever this thing is it like a jellyfish? Woo! You can touch those in an aquarium in Gatlinburg, Tennessee. I did. And so maybe there's other places. Maybe you've touched a jellyfish. I don't even really know if this is a jellyfish. Maybe it's just a hexagon with little bubbles on the side. But how many lines of symmetry does it have? Well, it has 1 for each side, and then it has 1 for each point. Then the rotational symmetries, in order to get this corner to this corner, that'd be 60 degrees. And then, does it have point symmetry? Well, if it has 180 degree symmetry, rotational, it has point symmetry. So that's problem 1 and 2, and there's 3 parts. Then we skip down, and it says, which capital letters have 1 line of symmetry, which have 2, which have point symmetry? And so, capital letters. So if I said the letter N for Mr. Nyson, does it have line symmetry? No, because the top part would be here. Now the letter M would. Does the letter N have vertical symmetry? No. And does it have 2 lines? No, but letter X would. It would have 2 lines of symmetry. Now what about point symmetry? If I took the letter N and I spun it 180 degrees, where that corner goes to that corner, does that have point symmetry? Ooh, I think it does. And so you want to make sure you have that. Okay? And so it says all, so don't forget any in the alphabet. And so you can draw these. I got these already copied on the homework. On these ones, you're spinning around here. So on this problem, you're not just spinning at 90 degrees. If all you were doing is rotating 90 degrees, you'd be done. And if you're rotating at 180 degrees, you'd be done. But to make the whole figure have it, you got to keep going. And then that would have 90 degrees, and you draw it all the way around. This one here, if you have 2 lines of symmetry, well, this isn't symmetrical. And if you were going to make a line of symmetry, then you would flip this over here, and flip this over here, and flip this over here. Well, that would have 1 line of symmetry. Well, if you want 2 lines of symmetry, like right here, then you need to flip this whole thing up here. So you got to add multiple things into your picture. Okay? And then one more I want to talk about before we finish is here, a trapezoid with no symmetry. Is it possible? Can you make a trapezoid that has 2 parallel bases where you can't draw any lines of symmetry? Well, sure. I just drew one right there. Now, make it better than I did. Use your straight edge. Could you make one that has 1 line of symmetry? Well, maybe that would be an isosceles trapezoid, and it would have 1 line of symmetry. Can you make it so it has a point of symmetry, so it has rotational where you spin it? See, it might not be possible, because then you might get like a parallelogram or something where all 4 sides are the same. So you try to justify your answers because it says draw the figure. Otherwise say not possible. Okay? And then towards the very end, a couple more problems. 28 is just the multiples of 50. But then 29, which I drew out on your homework. How many planes of symmetry and axis of rotation are there? And so if we go all the way down here, this one's going to be really hard. And so you're going to get 10n plus if you can get this one. How many planes of symmetry does this have? Well, if you sliced it down the middle, well, axis symmetry is you put an axis right down the middle and you spin it. Would you always get the same shape? That's an axis of symmetry. A cone would have 1. Now, planes of symmetry is where you slice it, and would it be the same on both sides? Well, since a circle has infinitely many lines of symmetry, there are infinitely many ways you can slice the cone. Okay? Now, a cube, this is going to get tougher. How many ways can I slice it to get the same on both sides? That's not just one. That's one for every pair of opposite corners. So that's 1, 2. And then I got to turn my head and go 3, 4. There's a lot of these. And then I got to go, I could slice them this way. Oh man, I don't like this problem. 5, 6, you got to count those. And then you could slice them down the middle. Well, how many pairs opposite sides are those? And these are your planes of symmetry. Now your axes of rotation are, if you drilled a hole through this and put a metal pole right through the center, you could spin a cube, so you got 3 pairs, so you can spin them there. But then you could also drill a hole from opposite corners here, and would that spin if you put the dice on the side and spun it? Well, yes, it would. And so you got to count those. And then the toughest one is this. A tetrahedron. Put 1 for each corner. Okay? Are those the only ones? And then if I was going to slice it, I could slice it like that. That'd be a slice. Now, how many of those do I have? And are there more? Oh, I could Google it. And then see, maybe someone else has been discussing this problem. I could collaborate. So you just give me your best on those last ones. Try to draw some stuff so I see that you've interacted with the problem. Okay, so we miss all you guys, and we dressed up, wore a tie for you today. Mondays, I know they're tough, especially when the sun's shining and we all have to be home. So hang in there, and we miss all you. Email me, let me know, and as soon as you get me your homework, soon we can get, I'm going to try to get Power School all updated. Okay, so all you guys, we miss all of you, and have a great day. Okay, bye-bye.